Hey everybody, welcome back. Today we're going to be talking about the converse of the Pythagorean theorem. Now before I get into the definition of converse, I want to quickly review what we learned last week. So last week we talked about the Pythagorean theorem, which again is a squared plus b squared equals c squared. And this theorem, which applies only to right triangles, allows us to find a missing side of a right triangle when the other two sides are given to us. Now, A and B correspond to the legs of the right triangle. So the legs are represented by the two sides which create the right angle in the right triangle. The hypotenuse, also known as C, represents the longest side of the right triangle. This is also the side that is directly opposite the right angle. So you have two legs and a hypotenuse that make up the sides of a right triangle. So in this particular example, number 1, we're going to find the missing side of the right triangle, which just so happens to be our hypotenuse, because you'll notice that side is directly across from the 90-degree angle. So plugging in the square root of 18 and the square root of 18 for A and B, since these are our legs, I'm going to take the square root of 18 squared plus the square root of 18 squared. And I'm going to set these equal to, instead of using C, I'm going to use the x that they gave us in the problem to represent our hypotenuse squared. All right, so simplifying this left side that's in blue here, I take the square root of 18 squared. Now, the square root and squaring are inverse operations. So in this case, they actually cancel each other out, leaving us with just 18. And the exact same thing is going to happen here. Our squared is going to cancel out our square root, leaving us with just 18 once again. Now that right side of the equal sign, that stays the same, that just stays x squared. Continuing to simplify the left side of the equal sign, which is in blue, 18 plus 18 is 36. And I set that equal to the right side of the equal sign, which is x squared. To get just x, I take the square root of both sides to undo that squared term. So now I am left with x equal to the square root of 36. Now remember, on your calculator, to take the square root, you are going to hit second and that x squared key to pull up the square root option, type in 36, go ahead and close the parentheses, and hit enter. Now remember, when solving by taking square roots, you typically end up with two answers, a positive and a negative. In our case here, because we're talking about the length of a side of a triangle, length can really never be negative. It just doesn't make sense. So we're only going to focus on the positive value that's produced when we take the square root of a number today. So the side length x, which in this case is the hypotenuse, it has a value of 6. So this is what we did last week. We applied the Pythagorean theorem to help us find missing side lengths of right triangles. Now today, we're going to do the converse of the Pythagorean theorem. Now converse basically means we're going to be switching the narrative a little bit. So instead of knowing that we have a right triangle and using that fact to find missing side lengths, we're going to instead be given the three lengths or the three side lengths of a triangle, and we're going to use the Pythagorean theorem to determine if the triangle is in fact a right triangle. So we're just switching it up here. So instead of knowing right off the bat that we have a right triangle, instead we're going to determine based on these side lengths that we're given if the triangle that we in fact have with those particular side lengths make a right triangle. So here we go.
By substituting the side lengths into the Pythagorean theorem, we can perform a check to see if the sum of the squares of the legs are equal to the square of the hypotenuse. This is how we're going to use the Pythagorean theorem to help us show that a triangle is a right triangle. So now the difference between what we did last week and what we're doing today is today we're giving you all three side lengths of a triangle, and we're going to prove that this triangle is right. Okay, now some of them they will be, some of them they won't. The Pythagorean theorem is going to help us test it out. So here we go. In example 1, it says determine whether the triangle is a right triangle. All right, so let's think about this for a second. We know that a right triangle has two legs and a hypotenuse. The hypotenuse is the longest side. So if I were to label the sides of this triangle, I would say that the 9 meters, this is a leg, and so is the side that measures 12 meters. And the reason for that is these are the two shorter sides. The longest side, which is 15 meters, this would have to be the hypotenuse because the hypotenuse is the longest side of the triangle. So now that we know which represent our legs and what represents our hypotenuse, let's plug into the Pythagorean theorem. So I'm going to take 9 squared plus 12 squared, and I'm going to set that equal to 15 squared. 9 squared, 9 times 9 is 81, plus 12 squared, 12 times 12 is 144, equals 15 squared, oops, which we don't need a parentheses anymore, which is 225. So our goal is to get this left side that's in blue to equal the right side that's in red. If these two things are equal, then we have a right triangle. If these two sides are not equal, then we don't have a right triangle. So 81 plus 144, that is 225. Now, does that equal my right side, which is also 225? Yes, it does. When the left side equals the right side, we've got a right triangle. So yes, if we're given a triangle with the side lengths 9 meters, 12 meters, and 15 meters, we have a right triangle. And we prove that using the Pythagorean theorem. Let's take a look at number 2. Determine whether the given side lengths would form a right triangle. All right, so the first thing we need to do is we need to identify what two sides represent the legs and what side represents the hypotenuse. So the legs are the smaller two sides. So the two smaller sides are 32.5 and 39. The largest side, or the longest, I should say, the longest side is 48.5. So that's going to be our hypotenuse. So plugging these values into the Pythagorean theorem, here are my legs. Here's my hypotenuse. And our goal is to make sure the left side that's in blue equals the right side that's in red. So 32.5 squared, again 32.5 times 32.5 gives me 1056.25 plus 39 squared, which is 39 times 39, that gives me 1521, equals 48.5 squared, and that gives me 2352.25. All right, so let me simplify this left side for a second, this blue side. So I'm going to take 1056.25. I'm going to add to it 1521. And when I do that, I get 2577.25, which obviously is not the same as 2352.25. Now, because this is the case, because these don't match, our left side does not equal our right side, then this is not a right triangle. This could be a triangle, it's just not a right triangle because it doesn't work in the Pythagorean theorem. The Pythagorean theorem proves that these side values do not go along with a right triangle. All right, let's take a look and let's just keep practicing here. We're going to determine whether each triangle would be a right triangle using the Pythagorean theorem. So if I give you a triangle that has side lengths 9 centimeters, 12 centimeters, and 17 centimeters, first thing, let's identify the legs and the hypotenuse. So the legs are the shortest sides. So 9 and 12 are the legs. 17 would have to be the hypotenuse because the hypotenuse is the longest side. Plugging these values into my formula, again, a squared plus b squared equals c squared. 9 times 9 is 81, plus 12 times 12 is 144, equals 17 times 17, which is 289. Does my blue side match my red side? Well, let's see. 81 and 144, if I add those together, I get 225. Does that equal 289? No, it does not. So is this triangle in number 1 a right triangle? No, because it does not work in the Pythagorean theorem. All right, let's take a look at number 2. Number 2, if I'm looking at this triangle, first I'm going to identify the legs and the hypotenuse. So the legs being the shortest sides, 9.6 and 18, those are my shortest two sides. My longest side is 20.1, that would be my hypotenuse. Plugging into the Pythagorean theorem, 9.6 squared plus 18 squared gives me 20.1 squared. All right, let's see if these sides match. Let's see if the left side matches the right side. So my left side, which is my blue side, if I simplify that, 9.6 squared is 92.16. 18 squared, 18 times 18 is 324. And 20.1 squared, so 20.1 times 20.1 gives me 404.01. Okay, simplifying my left side, my blue side here, I'm going to add 92.16 plus 324. And when I do that, I get 416.16. Now, is that equal to the right side, to my red side, which is 404.01? It is not. It is not equal. So this is not a right triangle in number 2. Taking a look at number 3. We're given a triangle. It does list, we cheated a little bit here. It does list the right angle box here. So let's just verify that that's actually accurate. Okay, so if I'm just really quickly going to check to make sure that the square root of 65 actually is the longest side. So if I do second x squared on my calculator to get the square root, I'm going to take the square root of 65 and I get approximately 8.1. So yes, this is the longest side for sure. So this is my hypotenuse. And these guys are my legs. Okay. So plugging into the Pythagorean theorem, let's just verify that this actually does work out and this is a right triangle. I'm going to take 4 squared plus 7 squared. And I'm going to see if it is equal to the square root of 65 squared. All right, so 4 squared, 4 times 4 is 16, plus 7 squared, 7 times 7 is 49, equals the square root of 65 squared. So remember what happens here. Our square root undoes, or I should say our squared undoes the square root. So we're left with just 65 on that side. All right, 16 plus 49 gives me 65, which is the exact same thing that I had on my right side. So seeing that my left side matches my right side, I'm a happy person. This triangle is in fact a right triangle. All right, let's take a look at number 10. Or number 10, oh goodness, number 4. Number 4, identifying the legs and the hypotenuse. So the shortest two sides, 10 centimeters, 49.5 centimeters, those guys are the legs. 50.5 would be the hypotenuse because it would be the longest side. So 10 squared plus 49.5 squared. Does that equal 50.5 squared? All right, simplifying both sides, 10 squared is 100 plus 49.5 squared. 49.5 times 49.5 gives me 2,450.25. And I'm going to see if when adding those two things together, I get, let's see, 50.5 squared is 2,550.25. All right, so let's see if my left side, my blue side, matches my right side. So 100 plus 2,450.25, that gives me 2,550.25. Does that match my red side? 2,550.25. It does. We're matching. So yes, these values, if they represent side lengths of a triangle, would be a right triangle, or they would match a right triangle. Okay, taking a look at number 5. So our shortest two sides are going to be square root of 6 and square root of 15. My longest side would be square root of 21. Okay. Plugging these guys in. I'm just going to draw a line here to separate the two problems. The square root of 6 squared plus the square root of 15 squared. We want to see if that equals the square root of 21 squared. All right, the square root of 6 squared, the squared undoes the square root, leaving us with just 6. Same here, leaving us with just 15. And same on the right side, leaving us with just 21. 6 plus 15 gives us 21. Does that equal my right side in red? You betcha. So number 5 represents a right triangle as well. Looking at number 6, 9 inches, 12 inches, 15 inches. If these are the lengths of the sides of a triangle, is our triangle a right triangle? Well, let's check it out. This guy is a leg, this guy is a leg, and here's our hypotenuse because our hypotenuse is the longest side. 9 squared plus 12 squared equals 15 squared. 9 squared is 81. 12 squared is 12 times 12, which is 144. And 15 squared is 225. Adding my left side, 81 plus 144 is 225. Does that match the right side of my equal sign? You betcha. So we once again have a right triangle here. Taking a look at number 7, I'm just going to really quickly figure out what the approximate value of the square root of 421 is. So going to my calculator real quick, second x squared, 421. So the square root of 421 is approximately 20.5. So that definitely makes it our longest side. This is our hypotenuse. 14 is going to be a leg, and 19 is going to be a leg as well. Okay, so plugging in here, 14 squared plus 19 squared. Does that give us 20.5 squared? We will find out. All right, so 14 squared, 14 times 14 is 196, plus 19 squared, which is 361. Does that equal 20.5 squared? Oh, why am I saying 20.5? Whoops, I'm sorry. Does that equal, my apologies, we're going to take the square root of 421 squared. Sorry about that. All right, so the square undoes the square root, leaving me with just 421 on that side. Wow, that would have looked really strange if I left it as 20.5. Okay, so let's keep going here. All right, 196 plus 361, that gives me 557, which is definitely not equal to 421. So this triangle here is not a right triangle based on the side lengths we were given. All right, let's take a look at number 8. Which of the following are sides of a right triangle? Show all work to prove your answer. So these are the side lengths of 4 different triangles. We're going to see which one of these works in the Pythagorean theorem. So starting with A. With A, 5 and 5 would be our legs and 10 would be our hypotenuse. So plugging in these values into the Pythagorean theorem, let's see if they work. All right, 5 squared is 25, plus 5 squared is 25, equals 10 squared, which is 100. Does 50 equal 100? Nope. So A is out. It is not a right triangle. How about B? Looking at B, all right, so I have sides that measure 4, 5, and 6. Well, 4 and 5 being the shortest two sides are the legs. 6 would have to be my hypotenuse because it's the longest side. So plugging in the legs, 4 squared plus 5 squared equals the hypotenuse, which is 6 squared. 4 squared is 4 times 4, which is 16, plus 5 squared, 5 times 5, which is 25, equals 6 squared. 6 times 6 is 36. Adding together 16 and 25, I get 41, which is not equal to 36. So B is out as well. Those 3 side lengths do not create a right triangle. Looking at C, I have side lengths of 10, 24, and 26. So if that's the case, 10 and 24 would be my legs because they're the shortest two sides, and 26 would be my hypotenuse because it would be the longest side. So plugging into the Pythagorean theorem, both legs squared, added together, do they equal the hypotenuse squared? All right, 10 squared is 100, plus 24 squared. 24 squared is 576. Does that equal 26 squared? 26 times 26 is 676. Ooh, this looks promising. 100 plus 576 does give us 676 on the left side, which matches the 676 on the right. Yay! You don't even need to worry about D. Okay? If we did want to run through D really quickly, sorry, I'm just going to be a pain. 8 and 12 are the legs. 15 is the hypotenuse. So 64 plus 144, does that equal 225? It does not. Okay, so C is our answer. All right, so just real quick review. At the bottom here, we're going to show all of our work. So now we're going to go back to using the Pythagorean theorem the way we did last week, where we're given a right triangle. So we know for sure this is a right triangle. We're given two side lengths of the right triangle, and we're asked to find the third. So looking at this triangle here in number 1, we're going to find the value of x. If I'm looking at this triangle, I can see that 5 represents a leg, and so does x. And the reason I know both of these are legs is because together they create a right angle. 13 is across from the right angle, which means it's the hypotenuse. Okay. So plugging into the Pythagorean theorem, 5 squared plus x squared gives me 13 squared. 5 times 5 is 25 plus x squared equals 13 times 13, which is 169. Getting x squared all by itself, I'm going to subtract 25 from both sides, and that gives me x squared equal to 144. Square rooting both sides. Since I'm talking about length, I'm going to take the positive value here. X is equal to 12, and that was all for number 1. Looking at number 2, we're going to round to the nearest tenth. So looking for x in number 2, I can identify x as the hypotenuse. And the reason for that is it's the side that's across from the 90-degree angle. So knowing that, that means 3 and 5 are the legs. Okay, so 3 squared, which is 9, plus 5 squared, which is 25, equals x squared. 9 plus 25 is 34. And to undo this squared term, I'm going to square root both sides. So going to my calculator, I hit second x squared to bring up my square root function. Type in 34, close the parentheses, enter, and I do get a relatively long decimal, 5.830951895, and I'm going to round that to the nearest tenth, so 5.8. Okay. All right, last but not least, we're going to find the perimeter of the quadrilateral, and we're going to round to the nearest tenth. Oh boy, think about what perimeter means. Perimeter is when we add all the side lengths together. Now the perimeter of the quadrilateral, so the quadrilateral is a 4-sided figure. So the quadrilateral is this side here. Now you'll notice that the quadrilateral does have that line going through it, so it's kind of cutting it or slicing it into two right triangles. So in order for us to find the perimeter, which means we're going to add all sides, we need to know the value of all the sides, and we're missing one. We have no idea what length that side x is. So we need to find that side length, but we have to do a little bit of work first. Now, as I said, we have two right triangles being created from this quadrilateral. Now here's what I'm noticing. So I'm obviously going to be using the Pythagorean theorem here. If I want to use the Pythagorean theorem, I need to know what this side measures. In order for me to get that side length, I need to look at this triangle here. I'm going to look at this triangle first. I'm going to use the Pythagorean theorem to help me find that side length C. So looking at that bottom right triangle, side length C is directly across from the 90-degree angle, which means it's the hypotenuse. So let's go ahead and plugging into the Pythagorean theorem, I'm going to find the length of side C. All right, so 1 squared plus 3 squared, that's 1 plus 9, which is 10, equals C squared. Now, if I take the square root of both sides to get just a value for C, I'm going to notice that 10 is not a perfect square. So second square root or second x squared, 10, I get a really long decimal. So for right now, I'm just going to leave this as the square root of 10. I'm not going to do any rounding yet. I want to wait to round until I'm done with the problem, until I'm actually trying to find the value of x. So for now, I'm going to leave C as the square root of 10. Okay. So now let's take a look at this upper right triangle, if you will. So this upper right triangle, side C and this side length 1 here, these represent the legs, and side X represents the hypotenuse. So now, plugging into that upper right triangle here, I'm going to use 1 and the square root of 10 as the legs, and X as the hypotenuse. So 1 squared is 1. The square root of 10 squared, this squared undoes the squared root, leaving me with just 10. And that equals x squared. 1 plus 10 is 11. Again, still set equal to x squared. Now when I square root both sides to get just x by itself, now I'm going to go ahead and do my rounding because I'm actually no, not yet. I'm just kidding. I'm not going to do any rounding yet because I want to wait until the very end when I'm finding perimeter. All right, so just kidding. We're going to leave this as x equal to. If I take the square root of 11, sadly, it is a very long decimal. It's an irrational number. So right now, I'm just going to leave this as the square root of 11. I'm not going to touch it yet. Again, I'm going to wait to round until the very, very end. Okay, so x, this side x, has a length of the square root of 11. Okay, now we can finally do what we're being asked, and that's find the perimeter. So let's add all 4 sides of the quadrilateral together. So 1 plus 3 plus 1 plus the square root of 11 is going to equal our perimeter. All right, so 3 plus 1 plus 1 is 5 plus the square root of 11 equals our perimeter. Okay, so going to my calculator, 5 plus second x squared, 11, close that parentheses, equals a perimeter, rounding to the nearest tenth, of approximately 8.3. That's all of our sides of the quadrilateral added together. All right, we did it. So that is the converse of the Pythagorean theorem. We will see you tomorrow.